In this video, I am going to walk you through how to graph a trig function. So we're looking at the function y equals 1/2 the sine of 2x minus pi over 2. Remember, the standard form would be y equals a sine of bx minus c. Our amplitude, these are the things we're going to figure out. The amplitude is the absolute value of a, which in this case is 1/2. The period is 2 pi over b for us. That would be 2 pi over 2, which is just pi. And the phase shift is c over b, paying attention to direction here, but this would be negative pi over 2 over 2, which is negative pi over 2, divided by 2, which is the same thing as multiplying by 1/2, which gives us negative pi over 4. Because of that, the shift, that negative inside, is actually going to shift things to the right. So we're going to make this plus, and we're going to write that this is to the right, pi over 4. Okay, so the next thing that we want to do is figure out what our step size is, what our key points are, and then remember what the shape is. So our step size is going to be the period divided by 4. And remember, this happens because sine looks like this. We have 1, 2, 3, 4, 5 key points. That's 3 x-intercepts and a max and a min. So if we divide into 4 equal parts, that's what we're doing here. We're picking up what the endpoints of those 4 equal parts will be our key points. So the period over 4, so we're looking at pi over 4. That's going to be the space between each of those key points. And then what are the key points? Well, we're going to start at the phase shift and step out the step size. So we're going to start at pi over 4. The next one is going to be pi over 4 plus the step size, which is pi over 4. And that is 2 pi over 4, which is pi over 2. We're going to add another pi over 4. That would be 3 pi over 4. And add another one. That would be 4 pi over 4, which is pi. And then add one more, and we get 5 pi over 4. So notice we have 1, 2, 3, 4, 5 key points now. And those will give us the 3 x-intercepts and the max and the min. Okay, so let's put this on a graph and see what it looks like. I'm going to put those key points on here. So I have pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. One thing to notice, you guys, this distance from 5 pi over 4 back to pi over 4, that's 4 pi's over 4, which is pi, which is the period that we got just above, which is what should happen. We're trying to graph one complete period here. So remember, sine, like I drew up here, can you see where I am up here? Like I drew up here, the sine of the sine function starts at 0 and goes up. This is going to do the same thing. So it's going to start here at our phase shift and go up, and what we're going up to is 1/2, which is our amplitude, and we'll go down to negative 1/2 eventually. So we'll go up and then down to 0, then back down to our minimum at negative 1/2, and then up to 5 pi over 4, and then connect those, and we have graphed one period of this sine function. And graphing cosine is really similar. It's the same steps, just cosine starts at 1 and goes down typically. So if A is negative, you would start at negative your amplitude. It would be flipped. Okay, if you have any questions, let me know.